A very good morning, and you're welcome to today's Signpost webinar. I hope you're keeping safe and well wherever you're coming to us from today. The series is brought to you by Teagasc in collaboration with Dairy Sustainability Ireland and the National Rural Network and Food Drink Ireland SkillNet. As we witness the great tragedy unfolding before our eyes in Ukraine, our hearts go out to all those caught in this unnecessary war. There is growing frustration across the world with the sense of helplessness. However, I know that there are wonderful humanitarian agencies working hard to alleviate the suffering and distress being endured by the people of Ukraine. And if you haven't done so already, I encourage everyone to support these agencies in any way they can. The war in Ukraine has sent shockwaves across food and fuel supply chains. And this week, the European Commission has proposed an outline of a plan to make Europe independent from Russian fossil fuels before 2030, starting with gas, in light of Russia's invasion of Ukraine. The Repower EU is a new package of measures which aim to double biomethane production from anaerobic digestion to 35 billion cubic meters by 2030. And it's expected that farmers across the EU will be incentivized through the cap to produce this biomethane in a bid to reduce Europe's reliance on Russian gas. So today we'll be discussing meeting our sustainability targets in agriculture at the Agri biomethane opportunity. And I'm delighted to be joined by David Hagan from Sustainable Agriculture Manager with Devenish, and Russell Smyth, who's partner with KPMG. Gentlemen, you're welcome to the Signpost webinar.
Hi, Mark. Good to be here.
Good morning.
And we're also joined by Padraig Foley with Teagasc, who's going to help us with questions later on. Good morning to you, Padraig.
Morning, Mark. How are you?
Great. So maybe starting with you, David, perhaps you could just give us a little bit of background to the work that you're doing with Devenish. Obviously, sustainability is a very important part of the work that you're doing in Devenish.
Absolutely, Mark. So my role consists of maybe taking the learnings out of our research farm up in South County Meath. The Heartland project is going on there, doing a lot of work there. So taking the learnings and the insights out of that, making them actionable and practical, and how do we implement them and build a capacity on Irish farms to be more sustainable in the future.
Great, thanks, David. And Russell, could you tell us about the work you're doing in KPMG?
Yeah, so I lead our dedicated ESG and climate advisory practice known as KPMG Sustainable Futures, and we're helping corporates and public sector really go on the ESG and decarbonisation journey. We do an awful lot of work in the agricultural sector, and we've also, for the last 10 years, been working in anaerobic digestion biomethane. And to date, we've supported the deployment of about 50% of all anaerobic digestion on the island of Ireland. And so we're going to bring some of those learnings to today's discussion.
Great. So it's a really hot topic. Obviously, the situation in Ukraine has focused our minds on our sources of fuel. So this couldn't have come at a more opportune time. So what we'll ask you to do, I think, David, you're starting the presentation for us, to share your screen with us. And just before you do that, David, just to remind everybody that you can submit your questions using the Q&A tab. And today's session is going to be recorded and available on the Teagasc YouTube channel, along with the presentation on the Teagasc website. So David and Russell, I'll hand over to you, and looking forward to your presentation.
Great, thanks a lot. So look, good morning, everyone, and thanks for joining us. So KPMG and Devenish were engaged recently by Gas Networks Ireland to undertake a study titled Meeting Our Sustainability Targets in Agriculture, and it's looking at a report trying to address some of the key challenges that have been identified on biomethane and its deployment in Ireland, and systematically looking at those and bringing evidence and real world experience to answer those questions. And so just to set a bit of background and context, so anaerobic digestion is considered a proven technology. There are over 10,000 examples of it deployed across Europe. There have, however, been a number of environmental and economic concerns cited, which has hampered its development in Ireland. And it is clear that Ireland is behind the curve in biomethane deployment. Northern Ireland has an awful lot of AD. There's over 90 AD plants deployed across Germany. There's many thousands you've France, you have the Netherlands, you have Denmark. So a lot of jurisdictions have mobilized and are mobilizing at pace on this. Ireland to date has been very hesitant on this technology, and that's been down to these challenges and questions which have been raised. So the aim of this report was to systematically address those questions and to provide the scientific and real world data. And we want to provide evidence that the development of a sustainable biomethane industry is technically feasible. What we've concluded, however, and you'll see later on, is that there is a risk that if it's not developed in a coordinated manner, there definitely is risk that there could be unintended negative consequences. So there are learnings from other jurisdictions. It has to be done right, but we have concluded that it is absolutely possible to deliver a sustainable and economically viable biomethane industry in the country. So the first sort of question that we have looked at is, does the development of an Irish agricultural-led AD industry align with current and emerging policy direction? So David, you want to flick on to that? So we've looked at a number of the core policy areas. So EU Farm to Fork, EU's biodiversity strategy, climate action plan, AG Climatize. And what's remarkable is just how many boxes the anaerobic digestion on biomethane industry would be able to tick. So just to take a couple of examples, the EU Farm to Fork is looking to promote a circular bio-based economy. And the AD sector is perfectly aligned to that. It's about taking farm wastes and other wastes, putting them through, converting them into energy, and then at the back end, using the resulting digestate as a fertilizer. So that's a perfect example of the bio circular economy. There's also an awful lot of push to move to organic farming, and the ability of anaerobic digestion to produce this nutrient-rich fertilizer at the back end is perfect to displace chemical fertilizers. And again, that very much aligns with where the biodiversity strategy is looking to go. And David will talk to other benefits that this could bring to biodiversity. The Climate Action Plan very specifically talks about exploring opportunities for farmers to get involved in anaerobic digestion, to increase the use of inorganic nitrogen or reduce their use of inorganic nitrogen fertilizer. And AG Climatize, again, calls for pilot schemes for on-farm carbon trading and anaerobic digestion. So this is one of the technologies which ticks so many boxes. And you can see, as was introduced by Mark at the start, the European policy level is also fully supportive of biomethane. It's one of the few opportunities we have to produce natural gas alternatives domestically and have our own security of supply. So the policy alignment, I think, is without question. And I think it's a very much a tick against that question. The second question, and probably the one that comes up most over the last 10 years that I've been involved in this sector, is, can Ireland grow sufficient incremental feedstock to supply a biomethane industry without impacting current animal feed dynamics? So I'd say 90% of the challenges that are put towards biomethane is that. So David, in particular, has led a lot of the research looking at the feasibility of this and how we can do this without impacting the feed available to Ireland's national herd. So hand over to you, David.
Thanks, Russell. Good morning, everybody. So yeah, so we are looking at the ability to grow more grass in Ireland, and I suppose the opportunity that we identified is soil fertility in Ireland. So again, this is building on our work in Doubt and looking at our soil improvement program. But when we look at the Teagasc Soil Atlas data, look, approximately when you take all Ireland into account, 20% or 21% of our soils are at optimum fertility. So that's optimum for pH, optimum for phosphorus, and optimum for potassium. So we look at this as the opportunity that if we can increase and optimize that fertility, we can grow incremental amount of grass that can be directed towards the biomethane industry over and above the needs of the national herd, over and above the needs of the national herd currently. And the second thing, opportunity there is obviously AD in its anaerobic digestion, in its design, is very circular. So 95% of the material you put into a digester is going to come back out as digestate. and that is going to be a better fertilizer, so it'll be more mineralized in your NPs and Ks. So again, that can displace artificial fertilizers coming into Ireland. Maybe just to give a little background on our thinking and how we developed this project, is that this project is of the knowledge capital produced in Doubt. In Doubt, we have the Heartland project. That is a systems experiment, and what it does, it directly compares multi-species forage to ryegrass to perennial pasture. So this is where we get our data from, and we are looking at the opportunity of correcting soil fertility, using multi-species forage to reduce our nitrogen input to produce this forage, and then targeting the lands in Ireland that are capable of being improved and having this output. So what we did at the start of the project, one, we had to look at how much land in Ireland is there available for multi-species forage. So to do this, what we did is we looked at there are 450 million hectares of grassland available in Ireland. What we did then was take off all high nature value land and natura land, so obviously that they can't be improved. And we also then looked at the land that was needed for the dairy industry and raising their young stock. This brought us down to a figure of 1.1 million hectares of available grassland in Ireland. We then further reduced this to 768,000 hectares of land that would be available to grow these feedstocks, just due to fragmentation and small farms. So the idea would be what farms would actually would this practically suit. The other thing, our other calculation in this then was, and look, this is based on the Teagasc Grass 10 project. If you look at grass production on dry stock farms in Ireland, currently it is approximately 6 tonnes per hectare dry matter. We looked at getting them up to 10 tonne per hectare dry matter as per the Grass 10 project. So we calculated that if we could get an extra 4 tonne of dry matter incremental over and above the 6 tonne, that we would be able to produce 3.1 million metric tonnes of dry matter in Ireland. When that is converted into terawatt hours, that converts to about 9.5 terawatt hours that grass production in Ireland could produce. Back to you for this one, Russell.
Yeah, so I think that, the overall conclusion on the feedstock is that AD and biomethane in Ireland will not happen if it is eating into feedstock availability for cattle. Therefore, it is all about producing incremental feedstock. And as David has shown there, Ireland does have sufficient capacity in our analysis to produce the incremental feedstock to support, a good sized level of biomethane production. One of the case studies we looked at is Northern Ireland. So Northern Ireland has deployed 90 AD plants between 2011 and 2017. And again, there was a fear in Northern Ireland that it was going to fundamentally disrupt the agricultural system. So we've looked at just what did actually happen over that period. So interestingly, deploying the 90 AD plants, it consumed an incremental 700,000 tonnes of grass silage annually in Northern Ireland. Over that time, the number of dairy cattle grew by 12%. The overall cattle numbers increased by 4%. So it certainly did not arrest or stop the growth in animal numbers. And the other stat that was interesting was farmland dedicated to grass actually increased over the period by around 25,000 hectares. And there was including an 18% increase in land with grass less than 5 years old. So this was suggesting that it did promote a renewed optimism and investment profile to bring land back into more productive use. And it's this bringing existing land that's already used for grass production, but reseeding it and optimizing its soil fertility to allow you to increase your average tonnage per acre or per hectare up, and using that incremental tonnage. So Northern Ireland demonstrated that it was able to support these 90 AD plants, which on a pro rata is broadly in line with where the number ROI wants to get to, and it didn't impact cow numbers. So again, that is a useful statistic and case study. So the third question we looked at, so we've said it's in line with policy direction. We've said that Ireland does have the technical capacity to grow this incremental feedstock. The third question then, would the development of the sector result in an intensification of agricultural activities, including an increased use of chemical fertilizers and pesticides? And this is a really important one, because there is no point developing a biomethane industry in Ireland to solve an environmental challenge if it actually results in the overall emissions in agriculture increasing. And that gas may be helping to decrease emissions in industry, but increasing them in agriculture. So it has to be done in a way which does not increase emissions in agriculture and does not increase the use of chemicals or other fertilizers in the sector. So again, David, if you would just talk us through the model that you've looked at of how this can be achieved without those negative consequences.
No problem, Russell. So we modeled this up on the Teagasc National Farm Survey data. So a 32 hectare suckler farm, what would happen on that farm, and we modelled two situations. So one, that the farmer keeps his current stock and sells the surplus grass to a local AD. And the other option then that we looked at too, if the farmer wanted to maybe get out of suckler farming and devote the whole farm to creating forages for anaerobic digestion, what would that look like too? And again, so just our model is based on correcting soil fertility, so a mass balance on soil fertility, and then it's also, just to describe it, it's a partial life cycle analysis. We account for all the production, or all the greenhouse gases arising from production, but we don't account for biogenic nitrous oxide, methane coming from soil, etc. That's not accounted for, but all production greenhouse gases are accounted for. So what we looked at in this farm is, and if we were to look at multi-species slaughter cattle, we look at the baseline year. So we created a baseline year for this farm, and what we did then, what on average they would be producing. Then we employed multi-species sward, and we employed a fertilizer program to maintain production and also to build soil indexes. So what we look at, we can go basically our baseline year from 194 tonne of grass produced to 312 grass produced. And then if we were to come across to year 5, that rises to 360 tonne produced in year 5. And we see that we're starting to level off. In terms of greenhouse gases, and I suppose this is the most important bit in this, is that in the baseline year, we're producing 122 tonne of CO2 equivalent per year. And what we see then in year 1, that actually decreases to 98. But crucially, when we compare back to our baseline year in year 5, we're on 111 tonne of CO2 produced. So what we're seeing there is that, and I'm going to come back, this is the circularity of AD. So as we go from year 1 to year 5, we need less artificial inputs there, and there's more nutrient coming from the AD, which displaces inorganic fertilizers and brings down the carbon footprint. Also, what we did in this model is that, look, we looked at carbon offsets and looked at the soil's ability to sequester carbon. And I suppose what we drew here from our own research in Doubt, but also now this is sort of shown in the literature. Dario Fanara's work in AFBI in Northern Ireland has shown that it's a long-term slurry experiment in Hillsborough, but it is showing that with medium to high applications of slurry, and we looked at the medium rate here, that soils can sequester anywhere from 0.3 of a tonne of carbon up to 0.9 tonne of a carbon per hectare per year. So we looked at that, and applied it to this model. So, and to get us to, when we take the gross carbon footprint minus what has been sequestered on farm, then brings us to a net carbon footprint. And again, what we're seeing is year 5 compared to year 1 and year baseline, basically we have a lower figure. So the question is, can we produce incremental forages for anaerobic digestion in an environmentally friendly way? And our model is suggesting that it is very possible. Just to talk then about the table at the bottom of the page. So if the farmer wanted to elect to get out of suckler farming and just convert the whole farm to multi-species forage, what would happen, and what we see in this scenario is, again, we can grow more grass, but what we are seeing is a drastic decrease in the carbon footprint compared to the one with cattle. And the hotspot in this is basically 69% of the emissions in the top table come from enteric methane and nitrous oxide from fertilizer application. So when we take them out, our carbon footprint drops dramatically. And again, if we're to look in the net carbon footprint, from a net carbon footprint point of view, we're actually seeing that potentially this farm is in a negative CO2, is in a negative space for carbon emissions, and is sequestering carbon on these farms.
So my overall takeaway from that slide is the average farm in Ireland could increase its production of grass silage by 85% without using any additional land, just by improving the soil fertility, improving its way it operates. And that's exactly, I suppose, at the heart of this. Can we use the existing land that's already used for grass production, improve its fertility, increase this incremental grass silage, and allow then AD to be developed without impacting the current use of the existing forage?
Yeah, that's very succinct, Russell. We again, as I said, the other part of this analysis then was looking at the mass balance of nutrients. So again, just to clarify, like the opportunity in Ireland at the moment is that 21% of our soils are at optimal fertility. And what we're looking to do, we're looking to optimize production rather than maybe maximize, so that if we could get up to, and we call it 10 tonne per hectare, as per the Grass 10 project, the model has actually shown that we will get to 11.2 tonne in year 5. What this page is showing, so on the left we have multi-species forage exclusively for forage, and then on the right we have multi-species forage and cattle. Just want to show you maybe the nutrient flows in this. So again, and I like to think of this slide, and maybe the best way to explain this slide is the soil indexes are low at the start. So we need to get them up to index 3. We can do that with the circularity of the digestate, but we're going to have to pump prime the system with phosphorus and potassium to get them to their target index 3. So that's always right. Once we pump prime it to index 3, then the circularity comes into action there then, and you don't need those external inputs. So after year 1, 100% of the nitrogen is supplied through the slurry digestate. So through the digestate, we don't need that. Our work in Doubt shows that the multi-species forests grow very well on 70 kilos of nitrogen per year. 49% of the phosphorus will be supplied through the digestate at the start, and 22% of the potassium will be supplied through the digestate at the start too. As I mentioned on the previous page, the reduction in artificial nitrogen and enteric emissions in this scenario will reduce the greenhouse gas emissions by 69%. And I said, and the life cycle analysis and the model shows that we can go from 6 tonne per hectare dry matter to 11.21 tonne of dry matter per hectare when growing exclusively on the farm, or growing multi-species forage exclusively on the farm. When we look at cattle, when cattle are, so we have half the farm partition for cattle production and half the farm partition for growing forage for the local anaerobic digester. 69% of the nitrogen requirement comes from the digestate, 42% of the phosphorus, and 28% of the potassium comes from the digestate. So again, at the start, external nutrients are needed, but once the fertility issues are satisfied, digestate, when it's exclusive for AD, we'll cover it, and when there's cattle involved, small requirements, less than 10% will be needed when there's cattle on the farm.
So the next question we looked at is, can an agricultural-led biomethane industry produce green gas which is able to meet the EU's Renewable Energy Directive 2, which is known as RED 2 requirements? So one of the big challenges, again, which is looked at, is that the biomethane produced to meet EU standards and be called a green gas has to have a CO2 footprint below a certain level, and that is going to drop down in 2026 to an even stricter standard. So agricultural AD is trickier than, say, waste AD. Waste AD is quite easy to meet this. Agricultural AD is harder, and so we've looked at the ability to develop a system which does meet that. If it doesn't meet that, there is no point developing this sector. So it's a very important threshold to be able to get comfortable one can meet. So David, if you just talk us through some of the analysis that's been done.
Yeah, so thanks. And maybe before I talk to that, I'd just like to thank the SEAI, Ricardo Energy, and Teagasc, and especially the people in Teagasc, Johnstown, for helping us out with these calculations. So in our report, we had three standard practices. So standard ryegrass as our control, the adoption of multi-species sward, and then looking at a hybrid rye clover sward. So to meet the RED 2 protocol, so the RED 2 is a Renewable Energy Directive, you have to reduce your carbon output or your carbon intensity by 70% by 21, which is represented by the blue line on the left graph and the orange lines on the two graphs on the right, and by 80% by 2026, so which is represented by the red graph on each page. What we look at in this analysis is the ratio of slurry to grass forage. So this is very important in an anaerobic digestion system, because slurry is a fantastic base for an anaerobic digester, but its calorific value is low because when you think about it, a cow is designed for millennia to take as much energy as you can out of her feed and leave as little energy as you can in her slurry. And that's why we're putting in the grass sward, because the grass sward is energy dense, and that gives you energy. But the slurry is fantastic. It's a fantastic base and medium and provides nutrients for the biology in the digester. So you're always, from an economic point of view, we're always looking at the balance between slurry and grass in a digester. So if we were to look at the table on the left, or standard ryegrass, it's telling us that, and we'll concentrate on the orange dots, that we would need between 40 and 45% slurry addition to meet the 21 target of a 70% reduction in CO2 from biogas. So that would allow us to call our biogas carbon neutral. When that goes then to our 2026 target of 80% reduction in the threshold, we need over 50% slurry in that mix. So to run an anaerobic digester on the standard ryegrass by 2026, we need 50% of the energy, or the feedstock into that digester would have to be slurry. When we look at the multi-species sward, and here we're concentrating on the blue line, in 2021, 30% of the feedstocks would have to come from slurry to comply with the RED 2 protocol. And when we got to 2026, we would have to be little over 40%. So approximately 42% of the feedstock would have to be slurry. And again, when we look at the hybrid rye and clover and how their compliance with RED 2, in 2021, we would need a little over 20% to be 20% slurry inclusion to be compliant with RED 2, and in 2026 we need 40% slurry. So what the two multi-species swards and the hybrid rye clover are showing, if I was an operator of an anaerobic digestion system, the profitability of my digester would be a lot more than the one on the left, because I can put more higher calorific feedstocks into the digester and extract more energy.
So the next question we've been asked, and the next question which we've looked at is would the development of the biomethane industry have a negative impact on biodiversity? So biodiversity as a topic is getting a lot more prominence in policy and also just in general. And the risk is, if you have lovely, lush, biodiverse fields and you come in and replace them with a mono crop, is that going to, and how badly would that impact? So I think if that's one of the examples of, if this is developed in an unstructured way, you can definitely see how it could have. So we've looked at how could you actually protect against any biodiversity loss, and could you in fact use this to increase biodiversity? So David, I'll ask you to look to that, please.
Okay, and I suppose what we've looked at, we broke this topic down maybe into two sections, Russell, and I'll start talk on maybe the resilience first. What we're looking at, the resilience on farm of using multi-species forward. These are results from 2020 on growing from the Heartland project. So the Heartland project is a systems experiment comparing perennial ryegrass against a permanent pasture ground and a 6-way multi-species forward and a 12-way multi-species forward. And look, what we're seeing is the 2 multi-species forwards at 70 kilos of nitrogen out-yielded the perennial ryegrass on 170 kilos. So it's growing approximately 2 ton more grass per hectare. But from a resilience point of view, and I just want to move to the chart on the right, and we look at specifically looking at the grey box. So in May 2020, I don't know if people can remember, we suffered a mini drought in Ireland, if we can say that Ireland gets droughts, but we definitely had a 6 to 7 week period of no rain. And what I just want to show on this chart is, so the green and the yellow are multi-species forwards, and the red and the blue are perennial ryegrass and permanent pasture. But during that drought period, the multi-species forwards were able to grow at a higher growth rate and provide more forage, thus increasing the resilience on farm, which I think is a very important point to make. From a biodiversity point of view, then, and just going to look at work done in Doubt and also work done in the Smart Grass project conducted by UCD, led by Helen Sheridan and Tommy Boland, and this work was done by Ola Smith. But we are looking at biodiversity. So obviously, when compared with perennial ryegrass, multi-species forwards, being 6 species or 12 species, provides more biodiversity. Provides more biodiversity by definition. We also we're carrying out earthworm surveys underneath our plots, and what we're seeing even after in 1 year is a 300% increase in earthworm activity under the multi-species forwards compared to the perennial ryegrass. So that's from a soil biodiversity point of view, that's very interesting, and also obviously from a nutrient cycling point of view, because earthworms have the ability to make inorganic nutrients organic and cycle better. The chart on the bottom of the page, this is from the Smart Grass project, and but what it is showing is, and if we look at it, we have grass on the top of the pyramid, legumes to the left, and herb to the right. But what we're seeing is, this is looking at parasitic wasps, is where you have the intersection of grasses, legume, and herbs, there is more biodiversity in those swards. So what we're seeing is in insects and in beetles, that intersection of the biodiversity is promoting more biodiversity in insects and beetles on top, and that's very interesting. And again, when we look at these from a wider biodiversity point of view, these species are at a lower trophic level in the biodiversity, but they provide food and energy to go up the trophic levels in a food system, and where we are seeing very good results in Doubt. But the theory would be that greater predators in that system will flourish on the back of this too.
5 minutes left, Russell and David.
No problem. So the next one is, can anaerobic digestion improve soil quality and soil carbon sequestration potential? And this is back to the ask of government can farmers have a role in further soil carbon sequestration? So, is there an opportunity here? David?
Very good. And the short answer, yes, there is an opportunity here, Russell. And again, as I spoke before, it's about optimizing soils. I suppose what we look at Devenish through our soil improvement program, we look at soils and it's about optimizing the health and nutrition, but it's looking at the physical, chemical, and biological aspects of soil. It's a three-legged stool; they all support each other. But getting onto carbon sequestration, and as I said, the model we used was we primarily used Dario Fanara's work to show this, and improving soil nutrition and putting digestate onto soil will increase the the sequestration in soil, and we're assuming the report or the model works on 0.3 of a ton of carbon per hectare, growing to 0.5 of a ton of a carbon per hectare in year 4. So as your soil, as your nutrition improves, so does your carbon sequestration. And actually, I'm just reading papers recently there, and this is sort of borne out again. There are further emissions avoided to this by data borne out in Teagasc Johnstown. That there's a paper there by Garmichael and Zervik again show that when P and pH are optimized in soil, nitrous oxide emissions are reduced as well. So this would be over and above what we're seeing here.
And then, so the last question here is, how could one ensure that an AD sector is developed according to best practice and does not produce unintended consequences? So as was shown in the last sort of number of questions, if you just left this to chance, there is a risk that it is developed in a suboptimal way. So how would you go about it? So one of the ideas that has been put forward is the development of an anaerobic digestion charter. So effectively a charter which could be voluntary or potentially linked to the green gas certification scheme or something, which puts down requirements on the development of the sector and has, for example, sustainability criteria. So for example, RED II alignment, which will already be baked into the green gas certification scheme, but also perhaps going further. So having limits on the type of land that can be used to supply feedstock in, the biodiversity metrics that must be adhered to, etc. The inability to put extra fertilizer or inorganic fertilizer down. So effectively ruling out a charter which brings together all of the best practice that the sector has gained over the last 20 years across Europe, the experience domestically in Ireland for the small number of AD plants that are there, those in Northern Ireland, and bring this down and provide farmers and those developing the sector with the tools to allow them to develop this in a way that ensures it delivers the benefits, but without the negative unintended consequences. So I think that's largely the end of the formal presentation. I think there is now a bit of time for Q&A, and the report in its entirety is available on the Gas Network's site, and there's a link on the screen there now.
Great. Thank you so much, Russell and David. Really, again, never been more timely a presentation given the situation that we find ourselves in. I suppose a general comment for you in relation to the nutrition of these, feeding anaerobic digestion systems and the reliance on artificial nitrogen to support that. Then, how do you see that working in the future, given the shock that has hit the system at the moment? Should we be looking at systems that decouple ourselves from the use or reduce our reliance on artificial nitrogen?
Yeah, I'll have a go at that first, Mark. I look, absolutely, and I'm thinking, and even look, legumes are the answer here. Like 78% of our atmosphere is nitrogen. Legumes have the ability to convert that nitrogen into a plant available thing. So that would be a USP for Ireland. So the multi-species swards and clover-rich swards, red clover silages, etc. I think that is the one of the best technologies that we have to hand today to reduce our dependency on artificial nitrogen imports.
Okay, there's quite a few questions coming through in relation to the point you were making about the North, Russell, around that there was no difference appeared in relation to the production levels, if I understood that correctly. However, there is anecdotal evidence there to suggest that the presence of biomethane, anaerobic digestion in the North did drive the price of silage and conacre in that area, and that maybe that increased our stability in production was as a result of increased use of concentrates in the diets. Have you looked at that? Because I know there is a lot of concern there about this food versus fuel debate, and whether or not that would create additional competition in the market for land and grassland.
Just to add to that, Mark, sorry, Russell, a couple of the questions, Russell, are tying in that the systems are very different in the north of Ireland. You know, obviously the dairy system is quite indoors in comparison, and a hell of a lot more concentrates involved.
Yeah, and look, sorry, absolutely agree. The systems are different. It is our closest neighbour, I suppose, in terms. So it is useful still to draw comparisons. So I think, you know, like I've been involved in a large number of the farm scale ADs that are developed. So I've, you know, a good on the ground feeling for it. There is without question localized examples of where farmers were fighting over fields in their local region, which were feeding an AD plant versus historically into dairy systems. So definitely at a localized level, you're going to find plenty of examples of that. More generally, however, the concept was that, you know, Northern Ireland isn't perfect. The concept here is that we're not looking to compete. The same grass that's currently going into a dairy system or into the beef system will suddenly be converted to AD. The model that we're promoting here is about incremental feedstock production, and we have plenty of AD plants that were built by farmers in Northern Ireland, and they turned their land, which was already producing grass silage for their animals, and they turned it into, rather than just the grass just grew, they turned it into a focus and a system, and loads of them were able to double the amount of grass silage that they were growing in their land without doing anything particularly radical. They just never had a need for more grass silage because they produced enough for their cattle. When they tried, they were able to substantially increase the volume. And that's what it's about. This will not work if we're redirecting the grass silage away from cattle and we're competing for the same feedstock. This is all about Ireland using its land more productively to increase the volume and to redirect the increased and incremental volume to the AD sector. So if it's competing, this will not work. And that's where a lot of the research is done. Can we produce this incremental? And the answer is we can.
And are there other crops that could be, or other substrates that could be used to support AD plants? I know that there's food waste, and there's other sources of digestate or slurry that goes into these systems.
Like the optimal feedstock for anaerobic digestion would be waste. So using all waste, using food waste, using commercial food waste, using other waste. So waste is definitely the optimal. The problem with waste is that there is a finite volume of it. There are already 4 to 5 large AD systems in Ireland and Northern Ireland, which are soaking up an awful lot of the waste already. So if you want a sustainable, long-term and growing sector, you cannot base it on what will be a diminishing volume of waste, which we want to reduce waste generally, and it's already largely used up. That's where the UK got it wrong. They built a lot of waste plants, and those waste plants assumed at the start they were going to get paid £50 a tonne for the waste. They're now paying £30 a tonne because, you know, there's a finite volume. So if you want a scalable industry in Ireland, it has to be built on something that is scalable, and that has to be an agricultural substrate together with whatever wastes are still available in the market.
And maybe sorry, the other thing that we didn't look, there's obviously the tillage industry in Ireland and the arable sector. We didn't include that in the report because it's harder to quantify, but there is a big opportunity there for temporal maize, sugar beet or fodder beet crops, etc. there that could feed in locally to digesters as well.
Absolutely.
There's obviously huge interest in this area. We've a lot of people on board here today. And Padraig, there's a lot of questions coming through for the lads.
Absolutely, Mark. And one, like you mentioned, a sustainable system, and obviously with the current climate, we need it pretty quickly. So there's one question here that came in very early in play, just asking how quick can this be put together? Like from concept to production, is the timeline, are you looking at 5 years? That's it. Can you discuss the deployment rollout, the lead-in time for pre-development compliance from planning to environmental compliance? Both of these could take up to 18 months each. What's the likely scenario? And how long it can actually take?
Yeah. So like Northern Ireland is a reasonably good example. They brought in the subsidy support scheme, and 2 years later there was one AD plant had been deployed, but not an awful lot. So there definitely is a lead-in time. What I would say is that some of the work that's been done by the likes of Gas Networks Ireland, of some of the other representative bodies, is about getting mobilised now. There are already AD developers on the ground in Ireland with planning permissions in progress, with environmental permits in progress. So people are starting to mobilise. from a jurisdiction from an absolute standing start, I think those timelines could well be right. I hope we're not at an absolute standing start. We do have got some projects in the system already that are progressing. We've got an ability to learn, but it does require government to want this to happen. So the planning authorities are going to have to find a way of getting it through the system efficiently. And the other piece which we learned from Northern Ireland, if every farmer goes out and chooses a different AD technology, puts in a planning permission using completely bespoke, everyone does it from scratch. What we'd like to do is find some way of standardizing, of providing people with templates, with ways of moving their environmental permits along faster. Okay. But I think it's not impossible. You could have an AD plant within 2.5 years. I think 5 years is not impossible if you had bad luck, but 2.5 years is feasible. But we'd have to start now, and that's why we're trying to mobilize the sector.
Okay, Mark, there's a hell of a lot of questions here. If we try to couple a few together between us, we might fly through them quicker. I'm going to throw two at you, David. One in relation to the multi-species swards and the longevity of them, and like how long will they last? Will they deteriorate after the 2 years? And secondly, from a P perspective, if guys are putting out the digestate again and again and again on the same ground, if they're already in index 3, is this going to push them into index 4? And what do we do with the P then? And I assume the answer is something to do with taking the solids out.
Yeah, so maybe the first question, first there, Padraig. Look, multi-species swards, they're not going to last indefinitely. And the same way we put in a ryegrass sward, it's not going to last indefinitely. What we're doing, and what we're showing in the Heartland project, is they have to be managed a bit differently. So when we say that, and especially in this situation, it's a cutting situation, that you have to keep your mowing bar up probably 7-8 centimeters off the ground, so you're not cutting out the growing point of the red clover. So that you're probably mowing at you're letting it grow out longer there. So you will be mowing when it would be traditionally compared to a ryegrass crop that you'd think would be mowing for hay. So you have to let it that way. But look, they're not going to last forever. But again, we also have to think about the way we regenerate grass, that look, we can stitch in the legumes again, we can stitch in the herbs if needs be, and manage them that way. So there is active management there, and that's something we have to look at. And to your second question, and absolutely, look, we can separate out solids from liquids, etc. But you just do have to remember, and especially if you're in a silage cropping situation, that silage is quite sour on phosphorus and potassium. So you do need a large amount of nutrients running around this system to make it work. And at a very minimum, we have to replace the offtakes.
9.5 terawatt hours you mentioned, David. What proportion of the total grid is that?
I'm going to throw that one to Russell there. He'd know that one off the top of his head.
That's putting quite a high bar to me. So the overall target that I think industry is looking for at the moment is 2.5 terawatts of biomethane by 2030. So the 9.5 is a technical feasibility. I don't think we have an ability to deploy it in that time frame. So 2.5 terawatts by 2030, and that's around 125 individual farm scale AD plants at 20 gigawatt hours each. That would account for around 15% of the industrial and commercial gas that's used in the country. And that's just an important thing to mention here. If biomethane is always going to be in short supply, we're never going to have enough biomethane to displace everything we'd love it for. So it's about using it in a targeted way. And the biggest challenge and the biggest opportunity for biomethane is deploying it where there are no other viable decarbonisation options available. And the sectors that have been identified is that high thermal temperature uses. So for example, the milk drying sector uses an awful lot of natural gas at very high temperatures, and there are not that many viable technologies. Electrification is not feasible. And so it's about directing the limited amount of biomethane to those sectors that have no other options. And that biomethane becomes the cheapest available technology to decarbonize those. So if we could produce 15% of industrial and commercial gas use, that would go a long way to those sectors that don't have other options available.
If we make a farm carbon neutral or becoming even a negative because it's a sink, where do those emissions come off? Do they come off the energy sector or do they come off the ag sector?
It depends how we look at it. If we're looking at it from an inventory point of view, they would And we see the emissions would come off in soil, would be in the land use and land use change sector, and then the other emissions will be in the energy sector. If we were looking at this from a life cycle analysis point of view, and maybe to build on Russell's point there, for argument's sake, that if we had a Glanbia, Dairy Gold, etc., drying milk for sale to a consumer-facing brand such as Nestle, and if we were to look at as voluntary carbon credits in their value chain, then they would accrue. Or Nestle could buy them in their value chain, and they could be voluntary offset against their emissions, which would probably then end up in energy.
A couple of comments on why you're targeting the beef sector, guys. You mentioned dairy, and you seem to be leaving the land in dairy. And that ties into another comment just around the economics of AD. What potential revenue per hectare is there for somebody? What the setup costs are? What grants are available for setup, etc.
Okay. Well, I'll take the first bit of that, Padraig. Look, the opportunity is there in the beef sector to grow more forage, basically. So when we look at the average figures, that if we can go from 6 to 10, that's what the opportunity is. Again, on average, dairy farms are growing more forage, so incrementally the opportunity is less there. On the second part of that question, again, maybe Russell, would you have an insight into that?
So just repeat the second question again for me.
Just on the economics of AD, what possible revenue is there available for farms? I guess you're tying in with the Teagasc e-profit monitor and so on. And
so look, I don't have the stats in front of me. What I'd say though is that if you are a dairy farmer, you're going to be able to have more profitability from remaining in dairy. If you're an average beef farmer, there is probably a better economic return from producing grass silage into AD. What I would say though is Ireland does not have any subsidy for the gas. Now at the moment, current gas prices, biomethane is relatively cheap, and you'd have a very economic AD plant without question. I don't think we're predicting in the long term gas prices will stay at this elevated level. What the government is likely to announce fairly shortly is the introduction of a renewable heat obligation scheme. That renewable obligation scheme will put an obligation on any large thermal energy suppliers that they must purchase a proportion of their gas from renewable sources such as biomethane. And we're expecting that will provide a statutory demand for biomethane. And if those suppliers don't purchase the gas, they'll have to pay a fine, which will underpin a value for this biomethane. So we think there will be a statutory instrument which will create the demand. It'll create a price point that will allow this to be economically viable, and for the AD plant to buy the feedstock such as grass at a point that is sensible and attractive to the farming industry.
The government did mention, or there has been mention of the cap coming into play here to support farmers in rolling out AD plants. How do you expect that, or has there been any mention of how that might manifest itself? Are we talking capital incentives or actual incentives to grow feedstock? What's your thinking there?
Like, I'm not sure. I haven't seen any detail. I've certainly seen that mentioned. I think Europe did announce a 400 million package of grants very recently that individual jurisdictions can apply for. So we'd need the Department of Agriculture to effectively apply on behalf of Ireland. So there are European level grants aimed at stimulating more investment in the sector. The changes to CAP to support it, I'm not sure if the details are available yet.
As you mentioned, Russell, that it can be economically sustainable, obviously with prices going up. Does that take into account that the beef farmers will have to make the investment to set up the plant itself, or is it just supply? So say the question again. I assume if somebody's going to just take a round figure of 3 million to set up the plant, yep, and you maintain that moving from being an average beef farmer, obviously scale of farm, etc., has to come into consideration. But if it's going to cost 3 million to set up a plant, will that make the farm then more sustainably, from an economic point of view, viable than what it currently is? Is that your point?
Yeah, like I think ultimately there's going to be a level of investment, and it's not going to be. It's unlikely, given the scale of land needed for an AD plant. The average AD plant will need 1,000 acres of land to feed it with its multi-species swards or grass silage. So this is likely to be an AD plant located on a farm, supported by feedstock coming in from a number of
farms. So that's a question that came in as well, just around your vision for the AD sector. So if it's 1,000 acres, is it going to be a cooperative, or is Devenish going to sponsor a number of them across the country, or KPMG going to go out and get investors, or what's the vision?
Like the very first farm scale AD plant that I raised funding for was 3 individual farmers in Cookstown in Northern Ireland. They were a beef farmer, a sheep farmer, and I think a dairy or something. And the 3 of them came together, and between them they had enough land. They had enough slurry. They built it on a piece of land owned by one of them that was fairly central, and the 3 of them then owned a third of it. And that was a brilliant model. And they've found it a big success. They've expanded it. They've invested in further AD. And that's, I think, a perfect example of how the model could work.
Okay, just from a sustainability perspective, then there are a number of questions here around how far away. You mentioned 1,000 acres, or hectares, maybe. Excuse me if I got that wrong, but how many, or what distance? What's the max distance that the individuals can travel from to the core AD plant? And have you looked at the LCA of obviously upgrading machinery, the use of diesel, etc., etc.?
Yeah, so the numbers that David's included in the life cycle analysis includes the movement, the harvesting of the silage, the transportation of it from the field to the clamps, etc. So that's definitely been incorporated. In reality, when we looked at the optimum size, in theory, you can get a lot of economy of scale if you build a really, really big AD plant. The problem is you're then having to pull feedstock from further and further away. So there's an optimum size, and we think it's 20 gigawatt hours. Which gets you some economies of scale, but also allows you to source feedstock from a reasonable distance. We wouldn't want to be bringing grass silage more than, I think, 10 kilometers. You wouldn't want to be bringing slurry more than maybe 3 or 4 kilometers.
And David, would the sale, sorry, go ahead, Dave.
No, I was just going to, the other thing on that too, but like there are new technologies out there for dewatering slurry on farm, so that you can basically concentrate the energy. So if we can dewater slurry on farm with some type of maybe a mobile unit, then the economics of transporting that are completely different than transporting 90% water or 95% water.
And will we get to the stage where those farms will be able to export, and obviously given fertilizer prices and nitrogen prices where they are today, that they'll be able to export fertilizer to other farms?
Yeah, well, if you take the scenario that we're talking about there, like with a centralized AD plant, if all this is centralized, then we have the ability to separate into solids and liquid, so that we could get to a facility that, or to a point then where you could make specific blends that would go back to certain farms depending on their soil nutrient profile, and excess then could be sold within the community.
Okay. Have you looked at employment and how it can, or have you modeled that into the scenario for rural Ireland?
The report didn't look at employment per se, but Russell, I'd say you'd have a better idea of that.
Yeah, sorry, we have done a separate report. I just don't have the numbers in my head, I'm afraid. We did do a business case for biomethane rollout in Ireland, and we looked at the role from an economic contribution. I don't have the numbers in front of me. That's something we could always come back to.
Mark, we could give another hour at this.
Very easily, yes, indeed, and huge amount of interest in this topic. So, David, Russell, we might be getting you back again in some time in the future. But for now, we're going to have to leave it there. We're just out of time. Russell from KPMG and David from Devenish, we do appreciate your time in coming to present today. And a reminder to everybody that the presentation will be available on the Teagasc website over the coming days. Padraig, thanks very much for helping with the questions. And next week, we will be changing the date because of the St. Patrick's holiday weekend. We're going to be coming to next Wednesday morning, the 16th of March, and we'll be joined by Rory Summers, who is policy lead on microgeneration with the Department of Environment, Climate and Communication. So he's going to be talking about microgeneration support, the new microgeneration support scheme, which I know is a huge amount of interest at the moment. So that's continuing our team looking at energy production. So for now, we'll see you next Wednesday. Thanks to Padraig again for helping with questions, and to Yvonne helping in the background with the technical side. And of course, Andy Boland, our series producers. So until next Wednesday, we will see you then. And thanks again for all of your questions and your interaction today.
Have a good weekend.
Thank you. Bye-bye.